Okay, so this is another video explaining on the online homework number, I believe it's number 4. Yes, so basically the problem is we have a cone like this. That's bad, bigger one. Okay, and then what we want to do is we want to fit a cylinder inside. And we want to figure out what the maximum volume of this cylinder can be inside the cone. Alright, so I'm really making this video again with my left hand holding the webcam. It's only with right hand, so it might be a bit difficulty to see, but anyway. Okay, so how are we going to do this? So what we can do is, this is a 3D problem, right? It's really messy. So what we can do, we can make it 2D. So how can we make it 2D? So a cone, if you project the cone on a 2D thing, it looks like a triangle, right? Like that. And then if you have the inside, the cylinder on 2D is a rectangular. Like this. Okay? So now we want to maximizing this cone again. So first we want to figure out the volume for the cylinder, because we want to maximize volume. So volume equal to pi r squared h. So h is the height of the cylinder and r is the height, the radius of the cylinder. So this is h from here there, and this is r right here. Okay, so then we know the cone also has a radius, right? So this is r. So that r equal to the radius of the cone, and the capital H equal to the height of the cone. Okay, so now we want to find the relation between an r and h, because this is two variable. We don't know how to maximize with two variables, so we want to use it. And what we do, again, we use a similar triangle. So recall we from problem 5. Well, I think I did problem 5 video first. So again, A, B, C, D, E. Those triangles are similar, so we have A, B over AC equal to BE over CD. Here I mean the length. So again, if you look at this, you have two triangles that are similar, right? One is this triangle, one is a bigger one. Okay, so let's redraw it. So we have this triangle here, the small one on the top, and the bigger one in the bottom here, right here. So then, so we know the length of this over that. So again, we A, B, C, D, E. So we have AB over AC equals BE over CD. So how long is BE? BE is just the radius of the, if you draw the rectangle here, the cylinder. Oh, sorry. Okay, so here's better. So this is this half of the cone, right? So anyway, so we have BE. So how long is BE? BE just little r, right? So BE equals little r. And what about CD? CD is just the radius of the cone, so CD equals the capital R. What about AC? AC is just height of the cone, right? So it's capital H. What about AB? You can see AB equal to AC minus BC, right? So how long is AC? When AC is capital H, and you look at the BC is the height of the cone, the cylinder, so it's minus small h. So then what we have, we're going to have capital H minus little h all over AC is capital H equals BE little r divided by CD is bigger R. So then I want to solve for h, because here r is squared, so I don't want to square something really complicated. So it's easier to solve for h. So here I'm going to solve for h. So h times big R equal to just cross multiplication equal to little h minus little h times r equals to capital H times little r. Then you just I'm just going to move this term over here and move this term over there. I'm going to get hr minus h times little r equals h times big R. So little h equal to hr minus hr over r. So now you plug in this. So if you can see it back, all the way back to here. We're going to pi r squared times hr minus hr all over r. Okay, so now usually in the problem, this big H and big capital R is given. So the problem I have here, the H is 8 and capital R is 2. So if you have different problem, you will have different length. So once you have that, once we have this, you can see it, and we can have everything we need. It's one variable, right? It's only in terms of little r. Then we can maximize it and minimize. Okay, so this is problem 4 for 4.7 online homework.